Hello again everyone, welcome back to ptet.chemistry channel. So in this lecture tutorial, we'll continue this idea on reacting masses, where in the previous tutorial video, I have started talking about the importance of MR. MR could be for a molecule where we call it relative molecular mass. It could be a relative formula mass, which is just another name that we use for ionic compound molecular mass. But of course, ionic compound doesn't exist as a molecule. They just give it a different name. So relative molecular mass or relative formula mass, it is still MR. The way to calculate MR has been covered in work 4 for this particular topic. What is important is MR is for one formula unit. What does one formula unit means? It means 1 in front of the formula. So in our balance equations, when we don't have just one, such as this, we have 3, we have 2 and 2, and this is 1 because there's no number in front. This is 1 formula unit of C2H4. This is 3 formula units of oxygen. As you know, oxygen is diatomic. Diatomic means there are two atoms bonded together in that single molecule. So these are things from your chemical formula topic. So two atoms bonded together is what you call diatomic molecule. As you know, there are many other diatomic molecules such as hydrogen, H2, oxygen, O2, nitrogen, N2, Cl2, Br2, F2, etc. Even I2 as well, such as all the group 7 elements. These are carbon dioxide. Carbon dioxide is just CO2, but there is 2 formula units. So there's 2 of that CO2, and this is H2O as water, but there are 2 of that water because they need to balance the equations as something that you have done in work 3 back in the last topic. Now, what do we know? We know that the relative molecular mass, this means MR. Don't forget, MR is for 1 formula unit. So we'll talk about this in a little bit. Ethene is this C2H4. So there are 12 times 2 because the mass of a carbon is 12. There are 2 carbons. So 12 times 2. Where do I write? 12 times 2 because there's 2 carbons. Each carbon has a mass of 12. And then you sum up the mass of hydrogen. So there are 4 hydrogen. Each hydrogen is 1. So obviously this is given already. I am just showing you how to get the number 28. The molecular mass of water, when they talk about the MR, they talk about 1 unit. As I mentioned, 1 formula unit. So even though there is 2 in front of that H2O in the balance equations, but relative molecular mass, meaning MR, is just for 1 unit. So we're just looking at H2O, just like that. So there's 2 times 1 plus 16 times, 2 because there's 2 hydrogens, 1 because there's the mass of 1 hydrogen, 16 is the mass for 1 oxygen, and there's 1 oxygen, so they give me 18. They actually want us to do the relative molecular mass of carbon dioxide. Do not forget, just like for water, is for 1 formula unit, MR is for 1 formula unit. So the MR of CO2, meaning there is 1 carbon and there's 2 oxygens. So 1 times 12 plus 16 times 2. You put that onto your calculator and you get 44. This is for 1 CO2 unit. However, we are talking about this topic. This is called reacting masses. So I'll just show you how to do the ratio. Ratio, direct proportion, those are things like cross multiply that we did in the last example, in the last tutorial video. So this is MR. MR is for 1 formula unit. I keep on emphasizing this because this will become very important in all the examples. This is 28 is for 1 formula unit. And we didn't get asked anything on oxygen, so I don't really need to write anything on oxygen. But if I want, I can write it, but it will be a waste of time since they didn't ask us to. But for oxygen, it will just be 16 times 2 for 1 formula unit. So we don't necessarily have to do this, so I write it in pink. 16 times 2 because the mass of each oxygen is 16. There's 2 oxygen, diatomic molecule. CO2 is what we have just calculated, so that is 44, and H2O is given is 18. But what is very important, this is the most important idea, this is called reacting masses. Okay, this is basically this topic. It's called reacting masses from the balance equation. Look at your balance equation. This is your balance equation given. So there is one of it. So it's just 28 times 1. So there's just 28. This is 32 times 3 because there's 3 formula units of oxygen. Not that they ask us, but I'll just write it here. I'll just change this to pink because this is not really what we need. So we don't really have to waste time on it. But it's just important for me to show you the idea in a little bit. The next one, you have 2 of that CO2. So 2 times 44 give me 88. I have 2 of the water. So 2 times 18 give me 36. So each of these, you can imagine it as a unit of gram, 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 and gram. When you think about it, all together, 28 plus 96, you get 124 gram. On the right hand side, you get 88 plus 36, and you get 124 gram. That is the meaning of balance equations, because the atoms have to be balanced. The masses, total masses on the left must be balanced with the total masses on the right, because you do not lose mass, you do not gain mass, you simply change matter from one form to the other in a chemical reaction. So what do I need here? Looking at the questions, I have 28 gram of ethene. I want to know how much gram of carbon dioxide and water does it form. So I look at this reacting mass. I have 28 gram here. So this is what I want. So if I have 28 gram of ethene, how many gram of CO2 and H2O will I produce? Based on these balance equations, I have 2 of that. So that is 88 gram. Very straightforward there. And this is 36 gram from 28 gram of ethene, which was the C2H4. Okay, the next bit is the one that is slightly tricky. This is 0.7 gram. No worries, because we can do our cross multiply. I just want the mass of carbon dioxide. So what I do is I just get C2H4 and carbon dioxide. So here it is. We're going to set out our equations. So C2H4 giving me 2 CO2. 28 gram. Because I'm talking about reacting masses, 28 gram of it, because 28 is the MR for 1 unit, and I have 1 of it. And I will put 88 gram here, because 44 is the MR. MR, as we calculated, is for 1 unit, not for 2 units. MR, molecular mass, is for 1 formula unit. But from the balance equation, that's why I write down the 2 there, is actually 2 of that. So again, it's 88 gram. So 28 gram of ethene, C2H4, give me 88 gram of CO2. How about 0.7 gram of ethene? When I have 0.7 gram of ethene, what is this? This is X. So what I do is I do cross multiply. So I cross that. So 28 times X is equal to, and then I cross the other side, 0.7 times 88. That's the meaning of cross multiply. The G is just the unit of masses in grams. So what I have is X equal to 0.7 times 88 divided by 28. I get 0.7 times 88 divided by 28. Press that onto your calculator. You get 2.2. The unit there will be gram, because everything there is in gram. So this is also in gram. So 2.2 gram is going to be the answer there. Moving on to the next examples. So this is a new question. This is called mercury 2 oxide. Mercury is a liquid metal. So there are only 2 liquids in the whole periodic table. One of them is a metal. Mercury is a liquid metal, and the other one is bromine. So mercury has this symbol, so Hg2 plus, because, well, it's a mercury 2, so it's a plus 2, the valency is 2, and you have O2 minus, the valency is also 2, and you know how to exchange and do the crisscross, and giving you the formula of HgO for mercury 2 oxide. These are the relative atomic masses, which you should be able to read from the periodic table, but the question is always very kind. They give it for you, and they give you the decompose, so the breakdown to give you mercury as well as oxygen gas. So just like all the other questions we have seen with this kind of questions, we have to think about MR. Remember MR? MR is relative molecular mass, is for one formula unit. I've got to stress this many times, because you've got to think about MR is for one formula unit first of all, before we think about the number in front. Okay, so if we're just looking at HgO, so that is given, that is 217, because there's just 201, well, one of the Hg plus one of the oxygen, 201 plus 16 is just 217. So should be no problem understanding that. It's just for one formula unit. Now, Mr is also the Ar if it's just the element. So for one formula unit, the Hg is just 201. And then for one formula unit, if it is one in front, it's just according to the formula. So there's 16 times 2 because this is a diatomic molecule. So diatomic means two atoms bonded together in a molecule. And there are many other elements, as I mentioned in the previous questions, like hydrogens, nitrogens, chlorine, etc., etc. They are diatomic as well. Anyway, 217 is equal to 201. Well, it's not equal because we haven't considered reacting masses yet. So it is the next part that we have the reacting mass, okay, or reacting masses. We need to think about, this is the most important thing, how many of it do we have? For one unit, we have 217. When we have two of them, so this is 217 times 2, I have 434, and this is 434 gram. And this will give me 2 of that Hg, so 2 times 201. And this give me 404. Let me just double check. Nope, 201 times 2 is 402. I couldn't do my math properly, so you need to check on your calculator. Don't forget that the oxygen will give you just 1 O2, so it's just 32 times 1, which is 32 gram. So there is the oxygen there. Let me just clearly label that. There's the oxygen there. Okay, so what happened then is these are conservation of masses. Conservation means does not change. 434 equal to 402 plus 32 gram. Anyway, jumping straight into the questions. So question usually very nicely lead from the balance equation. Balance equation was from work 3, which coincidentally, you don't really have to balance a lot of equations. Most of the time is given for you. You just need to understand how to interpret it in terms of the number in front. And there's your reacting mass multiplied by the mass for one formula unit, which was the Mr. So 434 gram of mercury 2 oxide will give you how many gram of mercury? They will give you 402 gram. Better write that properly. 402 gram of mercury, and they also produce you 32 gram of oxygen. All right. The next bit is the more difficult bit. This is the last bit of the question. For that 3 mark, you already gotten 2 marks just by being able to calculate Mr, just by being able to understand what is the number in front of the formula unit. Now, what do we know here? We want mercury 2 oxide, which is the HgO. We also want the mercury, which is just the Hg. So what I do is I pick out the information that I need. I have 2 HgO going to 2 Hg from the reacting mass. So I look always at the reacting mass, which I could process from the Mr. So that is 434 gram. As I had processed earlier in my working, I have 402 gram. So 434 gram of mercury 2 oxide will give me 402 gram of mercury. What does the question want? The question want 10.85 gram of mercury 2 oxide. So this one will give me X or Y or Z or whatever you want. So what happened then is you do cross multiply. So cross multiply means cross this side equal to cross the other side. So there's 434 gram, which is just 434 times X, is equal to 10.85 times 402. You could also do 402 times 10.85. It's the exact same thing because it's just multiplication, it's just math, and you should be able to do this because these are primary school mathematics. What you do next is you just press this number into your calculator. 10.85 times 402 divided by 434. My calculator give me 10.05 gram. Well, it doesn't tell me it's gram, but all of these are in gram, so my answer there is in gram after all. Okay, so that is 10.05 gram of mercury that comes from 10.85 gram. So it makes sense that the number are pretty close to each other as a result of the direct proportion ratio. So that's it for this lecture tutorial video. I've only covered 2 examples. I don't want to overwhelm and cover too many. What you can do now is you can revisit the same problem, cover it with paper, and try and do it on your own. And there will be many other examples, because just like math, we can come up with any calculation problem, and you should be able to do it with the same strategy, with the same method over and over again. Alright, thank you for watching. I'll see you in the next tutorial video. Don't forget to click the button on the bottom right to subscribe to the channel, and follow me at ptet.chemistry on Facebook, Instagram, and Twitter to get connected. See you in the next tutorial video.